Lesson 79, factoring out a greatest common factor. The terms of a polynomial that's factored completely will have no common factors other than 1. So in other words, something like 2x squared plus 2x plus 4 is not completely factored out because it all has a common factor of 2, because 2 can be taken out of all of those. So what we need to do is factor out that factor, and so we're going to take the 2's out of here, and remember how we do that is we take the 2 and we put it outside the parentheses, and then we take it off by dividing it. So 2 divided by 2 is 1, so we have x squared. Divide by 2 here, that's 1, so plus x. And then divide by 2 here, that's plus 2. And now we have something that's factored completely, that is a trinomial, that we can still factor into 2 binomials. And so we still have this 2 out front. And let me just move this down a little bit. Oh, I can't. Move it up. So that you can see here, now we're going to look, and we have x, and we have x, and we have positive, so we know we're going to add them, and they're going to both be positive, and we need factors of 2 and 1. So here's 2 and 1, will that work? That's plus 1 and plus 2x, that won't work. If we switch them around the other way, does that work? No, because that's still 2x and 1x, which is 3x. When a trinomial cannot be factored, it is called prime. So we were able to pull something out of this one, but x squared plus x plus 2 is prime, and we can't factor that. And there are many trinomials that cannot be factored. However, we did take out a greatest common factor, so we were able to factor out that 2. But once we got it down to this trinomial that had no common factors, then we could not factor it, and so this one is prime. And so this is what's left. So we've taken it all the way down to prime. So here's some other examples. If we have x to the 4th, and we have 5x to the 3rd and 6x squared, we can factor out an x squared. When we factor out x squared, we're going to be left with x squared plus 5x plus 6. And remember, I'm factoring out by dividing those off. And now I have this x squared out front, but I can factor this into 2 binomials. And again, it's x and x. 6 is 6 and 1, and I'm going to add those together, so 6 plus 1 will not give me 5. Other factors of 6 and 1 are 2 and 3, and 2 and 3, when I add them together, will give me 5, so plus 2 and plus 3. And you should just check out, is x squared plus 3x plus 2x plus 6. That will give me x squared plus 5x plus 6. So there's your final answer for that one. On the next one, we can factor out a 4, and we can also factor out an x. So sometimes you can take out variables and numbers. So here we're going to take out the 4x, so that's going to be x squared. Here we're going to take out the 4x, so that's going to be minus x. Here we're going to take out the 4x, and so we're going to have negative 20 left over because the x's cancel off, and 4 goes into 80 20 times. And then we can check and see if we can factor that into 2 binomials. So we have x and x, and we have 20 factors of 20 that when we subtract them, this says subtract, are going to give us a negative 1, because remember this is a negative 1 here. So factors of 20 that when we subtract them will give us a 1. Well, it's not 20 and 1, so then try next 10 and 2. It's not that. 10 minus 2 is 8. So next is 5 and 4. 5 minus 4 is 1. So it must be 5 and 4. And since this is a negative right here, negative 1x, that we're looking at, has to be a negative 5 and a positive 4. Again, check. X times x is x squared. X times 4 is plus 4x. Negative 5 times x is negative 5x, and negative 5 times positive 4 is negative 20. Does that give us our negative 1x we want in the middle? Yes, it does. So here is your answer. Factoring trinomials with negative leading coefficients. We have to be careful because we don't want anything to be negative in the front, because then when we factor into two binomials, one of these would have to be negative and the other would be positive. And so we don't want to deal with the negatives and positives in front. We want to deal with them in the back. So what we're going to do is we're going to get rid of that negative by factoring it out. And so we're going to take a negative 1 out of this. And what's left over when you do that? Well, we're just going to divide everything by negative 1. And what does that do? Well, it changes the sign. This was negative. That makes it positive x squared. This was positive, so that makes it negative x. This was positive, and that makes it negative 56. And now we can factor that into two binomials. Don't forget to leave that negative 1 on the outside. And so factors of 56 that will give us a negative 1 when we subtract them. So factors of 56 that when you subtract them, well, factors of 56, first thing that comes into mind is 7 and 8. And so 7 and 8, when you subtract them, give you 1. So x and x, 7 and 8. We want a positive, we want a negative, gotta look at the right part here. We want a negative x in the middle, so that means our 8 is going to be negative and our 7 has to be positive. Because that's x squared plus 7x minus 8x, and negative 8x and positive 7x is negative 1, and that's what we want up here. We completely changed that original equation, so don't look back at the original equation. So negative 1 times x plus 7 times x minus 8. And sometimes you'll see that written like this. And that's because that negative we know is a 1. That's that understood coefficient that's out front. So you'll see it written both ways, and so notice this. Explain why the product of negative x plus times x plus 7 times x minus 8 is the same as negative 1 times x plus 7 times x minus 8. Well, because this is really a negative 1 here. All that's doing is changing the signs. Factoring with two variables. So again, we've done this before. The first question you always ask yourself when factoring is, can I factor something out? So is there anything that these all have in common? Well, yes, they have a b in common, and they have an x squared in common, because this one has only an x squared. That's as high as we can go. So we're going to take the bx squared out, and when we do that, we're dividing bx squared off. So we're going to be left with x squared. Bx squared off, so that's plus 9x plus 20. And then we check and see if we can factor that. So bx squared times, this is two things, you're going to add them together. So here's add, to get a 9, and they're factors of 20. Well, factors of 20 are 20 and 1. 20 and 1 when you add them together is 21. 10 and 2 when you add those together, that's 12. 5 and 4 when you add those together, that's 9. So x and x, 5 and 4, and added together. And that's positive in the middle here, so they both have to be positive, not both negative. So bx squared times x plus 5 times x plus 4. This next one, we have an 5 in common, and we have an x in common, because the greatest number that we could take out anywhere is x. There's an x squared and an x cubed, but this last one doesn't have either an x squared or cubed. So we're going to take out the 5x, again, divide it off. That's, oh, they also have a b in common. So 5bx. So we're going to take the 5, the b, and the x off. So that's going to be x squared. Here we're going to take the 5bx off, and we're going to be left with plus x. Here we're going to take the 5bx off, and 5 goes into 60, 12 times, so minus 12. And then we're going to factor this into two binomials. So 5bx, and then x and x. And factors of 12 that when you subtract them will give you a positive 1. And remember, that's a 1 there. So factors of 12 that when you subtract them, so again, 12 and 1, that's 11. 6 and 2, that's 4. And 3 and 4, subtract those, that's 1. So we know it's going to be 3 and 4. And then we have to have a positive in the middle, so the bigger of these has to be positive, so positive 4, negative 3. And again, you can check that. X times x is x squared. And then x times 4 is plus 4x. Negative 3 times x is negative 3x. And then negative 3 times positive 4 is negative 12. And the negative 3 and positive 4x in the middle give you positive 1. Rearranging terms before factoring. You must always have the largest exponents first. So we need these in descending order, so I'm going to rewrite this as 7p squared k minus 14pk. And this is a third degree, this first one, because there's a 1 on the k and 2 on the p. The second one is a second degree because there's 1 on each one of those. And then the negative 10, or negative 105, k just has a single. So it goes degree 3, degree 2, degree 1. Then the question is, what can you factor out? So can we factor something out? A 7 goes into 14, but does it go into 105? So we have to check that quick. 7 goes in there once. That's 7, and that's 35, so it goes in there 15 times. So we can take out a 7, and we can take out a k, a 7, and we can take out a k. And so what we're left with then is we take out the 7 and the k, we're going to be p squared. Take out the 7, that's 2. And we take out the k, that's p left over. And we take out the 7, and that's going to be 15. And we take out the k there. So I just divided that off by taking those out of there. And then we see if we can factor what's left over into two binomials. P and P. This is subtracting. We're going to subtract the factors of 15 to give us 2. Again, 15 and 1, 3 and 5. 15 minus 1 is 14, so that won't work. 3 minus 5 is negative 2, so that actually is the right order then. We have to have a positive 3 and a negative 5. 3 times 5 is negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So 7k times p plus 1 times p minus 5. Last problem. Here's an application. The height of a golf ball hit from an elevated tee 40 meters above the hole is this equation, where t represents time. It says factor it completely. So the very first thing we check is, can we factor anything out? And so they all have a 5 in common, and we also don't want this negative in front, so we're going to factor out a negative 5. And when we do that, we divide everything by negative 5. And so this is t squared, and this is going to be a negative 7t, and this is going to be a negative, I don't know why I crossed that out and put it on top, but negative 8. So positive divided by negative is negative. And then we see if we can factor this. We have t and t, and factors of 8 that when you subtract them will give you a negative 7. Well, 8 and 1 when you subtract them will give you 7. So 8 and 1 when you subtract them. And we want a negative 7, so that has to be a negative 8 and a positive 1. Again, check your answer. T times t is t squared. T times 8, negative 8 is negative 8t. 1 times t is plus 1t. And 1 times negative 8 is negative 8. And so That is correct, because -8 and +1 is -7t.